Welcome to CivilizationX. Cancer often starts years before symptoms. The real bottleneck is signal detection. By the time you feel something, the biology may already be far ahead. That delay is lethal at population scale. Cancer caused nearly 10 million deaths worldwide in 2020. In the United States alone, 2,101,140 new cases and 611,720 deaths were projected for 2024. Now, teams at Google Health, the NHS, Oxford, Page, and Grail are training AI systems to read weak signals across mammograms, CT scans, pathology slides, blood fragments, and longitudinal medical records. By the end of this video, you will understand how AI detects pre-symptomatic cancer signals and why accuracy alone is not enough. At first principles, early cancer detection is an information problem. A small tumor may shed tiny amounts of circulating DNA into blood, distort tissue architecture at micron scale, or create faint spatial patterns in imaging long before a mass is obvious. Human readers work under time, fatigue, and perceptual limits. AI matters here because it can measure high-dimensional structure across millions of pixels, cells, or molecular fragments and compare them against prior labeled cases. Start with mammography. In a 2020 Nature study, Google Health trained a deep learning system on screening mammograms and evaluated whether it could classify malignancy from image patterns that radiologists may miss or weigh differently. Retrospectively, the model reduced false positives by 5.7% in the US dataset and 1.2% in the UK, while reducing false negatives by 9.4% and 2.7%. A second pathway is pathology. Page Prostate, authorized by the FDA in 2021, analyzes whole slide biopsy images and marks malignant regions, helping surface microscopic disease inside gigapixel tissue scans that are tedious to review manually. A third pathway is blood. In Pathfinder, reported in The Lancet in 2023, Grail tested 6,621 adults aged 50 or older. The model searched blood for fragment patterns consistent with circulating tumor DNA and predicted tissue of origin. A cancer signal appeared in 92 participants, about 1.4%, and 35 cancers were confirmed. Of those, 57% were stage 1 or 2, including cancers without routine screening programs. So yes, AI can detect cancer before symptoms, but only in specific channels and with specific limits. It can reduce mammography errors, flag malignant tissue on digital slides, and detect blood-based cancer signals earlier than symptom-driven diagnosis. Over the next decade, the target is a screening stack, not a single model. AI triage on mammograms and CT, opportunistic risk scoring from routine scans, blood testing for unscreened cancers, and personalized screening intervals built from records and biomarkers. The anomaly remains the same. Cancer can be biologically advanced while the patient feels nothing. AI does not remove that constraint. It changes where we look for the signal. For more first principles documentaries on intelligence and engineering, stay with CivilizationX. If this shifted how you see the future, share it with someone who needs to hear it, and join us for the next breakthrough.